Hello and welcome everyone. It's another Thursday, another big model release. I'm here with Chris today from NVIDIA.
Hello, what's going on?
Yeah, welcome Chris.
Thank you.
Today we are launching Nemotron Ultra.
Nemotron-3 Ultra, yes.
Very exciting. Last time you and me spoke, we launched Super.
Yes.
Great pleasure. So I think most people are just interested, what's new, what's hot, what's the difference?
So the big things are I think the big things are right up front. So it's a bigger model. It's 550 billion parameters, 55 active. So this is, compared to Super's 120B, is a much bigger model. A lot of capability comes with that exercise. So it's definitely a more capable model across the board. Nothing's really changed architecturally, meaning that the sparse MOE, hybrid transformer, Mamba, latent MOE, all of the bells and whistles that we had for Nano and Super are still there. So it has like MTP, 1 million context length, these kinds of things.
MTP mean? Just
multi-token prediction.
Okay.
So basically the model can predict multiple tokens at once and then verify them quickly. It just means you can like eke out a little bit more performance as in tokens per second from the model. Yeah, so it's like super but big is the idea. Yeah.
What does that mean for me as a developer when I'm trying this out on Base 10 or on any other cloud provider where I can access this?
Yeah, so there's a couple things that like will feel different between Ultra and Super. So when we were tying up Super, it was kind of when the agentic harness explosion was happening. So this is like the introduction of OpenClaw, now Hermes. Like there's been a lot of proliferation of kind of these agentic harnesses. Things like open code continue to be used a lot by the community. But the idea is like Super wasn't built with those in mind. It just happened to be good at them, which we're stoked about, right? But like we didn't build for that. Ultra we built for those harnesses, so that's gonna feel different. I mean, the best way I would say like Ultra's our first model that you probably aren't going to preferentially or preferably use in like a chat interface window. It's really meant to be powering a harness, so that's gonna feel a little bit different. Something that happened that I don't think was like explicitly planned for, but like it's pretty dope, is that it's got okay taste as it relates to like visual-ish tasks, so it can make like prettier websites than Super, and it can make more clean animations and stuff like that. Again, that's not like the highlight of the model, but like we're pretty stoked that kind of came with the extra capacity. So
that's awesome.
Yeah.
Let's talk about the shiny parts. Like what, we talked about Super. Super was also, especially in the context of CodeRabbit, used for specific tasks.
Yeah.
And now Ultra comes with a set of advantages, speed, cost being some of them.
Yes.
What are the ones that, technically speaking, me as a programmer using it, I should pay attention to?
I mean, you basically said them. So this is like frontier level intelligence, open frontier level intelligence, right? So this is kind of keeping pace with some of the big boys that you may know and love, your Kimmy K 2.6s and things like that. But it is like faster, and it's faster for like some obvious reasons, right? So like 1.6 trillion parameters versus versus 550 billion parameters. So obviously there's some advantage there. But also, like, again, all of the work that the team did to make it as efficient a network as possible really shine through. So you can expect that it will be able to crush a lot of tasks really quickly. From the GDC keynote, we had like a great chart, which was basically showcasing like the efficiency frontier, which is a Pareto series of Pareto curves for each model. And we're like close to we're approaching the frontier, right? To the most attractive quadrant, right? Well, that's where we're heading towards. We're very excited about that. And what that means for like devs is you can really do a lot more work per unit time with a model like Ultra, especially for tasks that don't require like PhD level intelligence or extraordinarily complex coding problems where no model is really going to get it done quickly. If you have tasks that you're just kind of trying to hammer through, like Ultra is just going to get it done super quick and efficiently. Efficiently for the developer might not mean anything because you're not really thinking about efficiency, when you're like hitting an API, right? But it matters to the providers of the model and the efficiency is felt as reduced cost for devs. So it's like the per token cost is going to be a little bit lower than some of like the bigger, less efficient models.
I think that's incredible. Let's put the ballpark also, or the model in the ballpark where it's appropriate, I would say. I brought a little image here that I wanted to go through with you, which kind of compares it to different other open weight models in the space. Can you explain a little bit
Yeah.
where you see the difference here between, Nemotron Super, Nemotron Ultra, as well as comparing it to things like Kimi K 2.7?
So this chart is basically showing us that Ultra is fast and smart, right? The idea is that like on the bottom we have output speed in tokens. This is the idea of like how many tokens per second can you get out of Nemotron-3 Ultra through like a third-party model provider, so like something that's not from NVIDIA, right? So like Deep Infra or Base 10 or Nebius, wherever you get your tokens from, right? That hosts Ultra, and that speed, as you can see, about as fast as like GPT-OSS 120B, significantly smaller model, doesn't come at a massive intelligence cost. So we're still in that kind of open frontier intelligence bracket, despite being, I think the official number is 5x as fast, which is, again, that's what it's meant to be, right? Intelligence is great, but we still think that faster models are smarter models. And so we're very proud that we're kind of in, the green box here.
Yeah. Maybe to talk a little bit more practical, like what kind of use cases have you been testing it internally on where you feel like it's really excelling and developers should be excited about?
I mean, there's a ton of stuff that we're working on. You can read all about some of that in our kind of release materials, as well as some of the release materials from different partners that have been able to try out Ultra. For me personally, I don't think the ecosystem has caught up to this yet, but we have really believed in this idea of like systems of models are the future. And so there's a lot of effort and energy spent like trying to figure out like the best model router. How do I use the appropriate model? And what I can say is that like more and more of the tasks that I care about are able to be pushed to Ultra, even from Frontier, like the proprietary Frontier space. Ultra just is so fast. I mean, it doesn't like 4%, let's say, on an internal use case that I care about. 4% accuracy loss like is meaningful, but like a 10 to 15x speed up is quite a bit more meaningful. And one of the things that, we like to talk about, 10 to 15x faster can kind of be thought of as I can run this task like 10 to 15 times in repetition, right? And get the same, output at the end of the day. So even if I have to run Ultra on a task like 3 or 4 times, I still have a massive speed up. I can kind of get my accuracy through those repetitions. So coding, obviously, Ultra is pretty decent. I know I'm biased, but I have enjoyed it a lot, especially the kind of like very tedious but annoyingly difficult tasks. So this is like writing actual integration tests or writing integration like suites or pipelines where you do have to kind of have that kind of long context understanding in order to really build something that can actually test what you're trying to build. And then like it is getting dangerously close to being great at kind of those auto research tasks because the speed and intelligence is really important there. So like you can crank through like 10 to 15 experiments at the same time as some other models might be able to do one. And that means that you can kind of, roll down the hill a little bit faster over time. And so I've found some great use for that, especially with some of the tools that we've been trying to equip our libraries with, so like skills and stuff like that, right? I think Ultra is a great user of those things, so like skills for say like Nemo RL or something like that. And again, we can just roll down the hill a little bit faster because each iteration takes significantly less time.
Yeah, let's talk about that for a second as well. And I'd love to show you some of the results that we talked about briefly when on our internal CodeRabbit benchmarks. What kind of harness are you using at NVIDIA when you're coding with it? Because I understand that NVIDIA does not like, Anthropic have its own Cloud Code or Codex or any types of these.
Yeah, I mean, it's interesting. So, like, I think so for Nano, I think we were worried about like benchmaxing, right? So in the Nano era of models, it was like benchmaxing was a problem. This idea that like you're just focusing on these benchmarks and you're trying to make number go up, and the models kind of doesn't generalize well outside of those benchmarks. I think we're now moving into a space where we're like harness maxing, right? Where
Mm-hmm.
the models are really good at like their harness, but maybe they're less good at like everyone else's harness, right? Or they're good at like whichever the highlight harness is, but they're maybe weaker with some other harnesses. So there's so many engineering teams at NVIDIA. There's so many preferences,
Mm-hmm.
between engineers and researchers that uh, we use it in like every harness, and so we built it to be good in like a wide range of harnesses. I'm a open code guy. Uh, Primarily when I'm using open source models. So if I'm not kind of locked into a proprietary harness, I'm just using open code, so that's how I use it.
Mm-hmm.
But our teams use like Pi or Kilo Code or Open Hands or
Yeah.
whatever combination of these harnesses. And I mean, the idea is we're trying to make it so it's great at all of those, not just like the one harness that you might care about.
And do you alter the harness at all in order to use it effectively for open code, for an example?
You can, yeah. I mean, like let's define a range. So I think the last time we talked, we talked about this as well, which is kind of like Claude's good at like divining intent, right? You can kind of just like talk to Claude and like Claude will get it, you know.
Mm-hmm.
Codex is like not very good at divining intent, but it's extraordinarily good at following explicit instructions, right? If you lay out the task extraordinarily well,
Yeah.
Codex is going to crush it extraordinarily well. I would say like Ultra is right now closer to the Codex style, where it does require you to be quite specific. It does
Mm-hmm.
benefit from really firm instruction. And so I think things like having very clearly laid out ideas for the way you interact with your harness. Like, say you have a skill, you might have a skill that like works really well for Claude,
Yeah.
but you want to make sure like it's more rigorously instruction heavy for Ultra. And there are some times that I've noticed that Ultra does benefit from like a little kick in the pants or some repeated instruction to kind of help it best understand what you want. So I would say like those are some tips for adapting it to your harness. The big thing is like the more explicit you can be, a la like Codex style, I think the more Ultra benefits.
Yeah, I think that is a beautiful segue into another piece of data that I brought here for this discussion here, which is
Heck yeah.
we looked at that as well. This is a result from our internal benchmark measurements. So what you can see on the top here is our our baseline, and then below that you see we plugged in NVIDIA's Nemotron 3 Ultra in order to measure it on more of we have multiple lines. These are for the junior bugs and problems that we find. And through that measurement, what you can see here is kind of like the retry metric. So we saw that it performed similar in terms of the amount of bugs it would find to our baseline. So equivalent performance for obviously significantly lower cost.
Yep.
As well as I think we were using ChatGPT 5.5 here. I would need to double check. But then we would find that sometimes the metal would get stuck in what we call the scratch pad phase, which is not entirely like figuring out the solution, but not making the decision to post the comment inside of a PR until we would push it again.
Yeah.
Yeah.
I think like so I mean this is a kind of a manifestation of what we were talking about. I think like one of the things that Ultra is surprisingly good at doing is working inside of like goal prompts. So goal prompts we used to call them like Ralph loops, right? So
Mm-hmm.
but the same thing. Like while loops basically, where
Yeah.
you keep prodding the model to continue to do work until the work is judged to be done. I think Ultra is actually extremely good in those scenarios because it does benefit from prodding. Like if Ultra gets stuck, it will tend to want to stop and ask for clarification or reach out to the user. And so having a system or using the features that come with basically every harness at this point, which is
Mm-hmm.
basically like either slash goal or the Ralph skill, is going to very disproportionately benefit Ultra because you give it that kick in the pants, and you
Yeah.
have like an outside system tell it when it's done, as opposed to uh, relying on Ultra to continue the work without that kind of reprompt.
Exactly. And another metric that we should mention here that's not displayed in the data that we're looking at right now is that it's still finished faster than the baseline, actually, by a little bit. And yeah,
You love to
marginally
see
even.
it.
Exactly. So the retries actually did not really affect ultimately the outcome.
Yeah, this is what I'm saying. Like,
Yeah.
I know it's like it's like it's not the way that we use these tools often right now, but I mean the idea is that if you give a really really fast model
Mm-hmm.
a few chances at the task, where Ultra is right now, it's likely to get to a spot that you're very happy with, and that
Mm-hmm.
net process is still going to take like significantly less, or at least less time than you might get from a model that like quote unquote one shots the problem, but like just takes forever to think through it, right? So and that's why in that graphic that we talked about earlier, like we care about like time or cost to complete,
Mm-hmm.
rather than like net tokens or net turns or something like that. I mean, the idea is I don't really care how many tokens it costs, right? Because like tokens are dope, but they all cost like an amount, and that amount is usually proportional to the size of the model in some way.
Yeah.
And they take an amount of time to complete, and that's like ultimately what I care about. Like if I can run Ultra overnight and get 8x tasks done,
Mm-hmm.
and burn through more tokens that are cheaper, I'm just as happy as if I use a slower model and maybe it doesn't get everything done in the night.
Yeah. I'll be interested actually to learn a little bit more about the architectural decisions that you then made to achieve that outcome, because that seems to be a very specific goal. And we also just saw that other open models don't really achieve that same performance level of speed and intelligence. So what's the secret sauce that you can spill?
Yeah, I mean, so it's a bunch of things.
Yeah.
So I love this question because like the answer is like there's a ton of confounders, right? So
Yeah.
obviously the actual network itself, so the hybrid Mamba transformer attention is a big thing because we know that people are just gonna like dump in, I mean, like blocks and blocks of context, and
Mm-hmm.
so that long context performance is extremely useful. MTP, so multi-token prediction, is extremely useful. Latent MOE, which is allowing us to kind of again have a more efficient network, is very useful. The number of experts that we have, the number of the ratio between the SSM and transformer attention that we have. I mean, all of these decisions kind of
Accumulate.
are like a grain of sand that just kind of piles up to this this very efficient beast at the end of the day. I would go so far as to say like almost every decision made in the model is in some way a concession to a faster, more efficient model. Like that is the thing that the team is most excited by. NVFB4, obviously, gotta shout out my boy NVFB4.
What is FP4?
So it's it's a quantization. So
Mm-hmm.
instead of running the model like BF16, you can run it NVFP4, which goes very fast on especially Blackwell architecture. But with Ultra, we're very excited because so in previous versions we've always released like BF16, FP8, NVFP4 because
Mm-hmm.
NVFP4 won't run on Hopper, right? It's for Blackwell. But for Ultra, we're limiting the release to just BF16. Got to release the full precision weights, and then NVFP4 because the team cooked really hard to build kernels that allow you to run NVFP4 on Hopper and Ampere. So the idea is,
You're opening up the ecosystem truly
well,
more.
we just don't want you to not be able to run NVFP4 on
Yeah.
Hopper, right? That's something that we want people to be able to do. Still run
Yeah.
a smaller model, still run a more efficient model, and then just have some kernels that make it work on the back end. So anyway, every choice
Mm-hmm.
is made, and that's part of that like extreme co-design vision that you might hear Jensen refer to pretty often, which is this idea that like the hardware is designed with the model in mind, which is designed with training in mind and inference in mind, and then that
Mm-hmm.
informs the hardware, which is then designed with the model in mind. So it's like this co-design circle that exists, but that's a very long-winded way to say like every choice we made in some way is I said the word concession earlier. Probably what I mean is made with efficiency in mind.
Yeah.
Yeah.
Should we give it a try? See what it can
Yeah,
do?
do it up. Let's see it. Let's see it go.
All right, awesome. So I got a little screen recording here. I'm gonna swap over to one of the tasks that we talked about earlier.
Yes.
So let's see what it can do here. Tell me a little bit about what we are ingesting here.
So basically, I mean, we had to pick something that was like quick enough that we could see it in kind of in the model's wheelhouse. It could do stuff like, again, it could like make the pelican on a bike and you know, these kind of like fun toy examples. But this is like just reading a bunch of papers. No, I'm saying a bunch, it's 4 papers, just so we can do it quickly, but reading some papers and then reasoning across those papers. This is kind of like I think a relatively standard way that people might use their models today, which is basically like, here's a bunch of stuff, tell me about it. And so that's basically the task. It's just going to reason across these loop transformer papers, and hopefully it'll tell us something cool about the sizes of those models.
Yeah, awesome. Let's check it out. So we're gonna use open code. I'm gonna paste this here.
And we'll get the famous pasted some number of lines.
Yeah. There we go. We just got the papers here. So now it's fetching.
Yes.
And there we go. Look at the speed of that.
Oh, it crushes. Yeah, it's fast. Yeah,
Yeah.
it feels fast when you use it, which is nice.
That's true. Yeah. That's, I think, one thing that I've been missing lately a little bit more, especially with Opus 4.8. It's just I don't feel as attached to the process anymore. I'm not really staying in the loop as much. And it just, then I start working on something else. And yeah, but let's talk about that. Let's have a look.
If we were to like kind of take what you're saying a little bit further, I think Ultra is like a really good interactive model. So I think that we're getting to the point soon, if not already for some people, where latency is so high that models are kind of like a background process that happens throughout the day that you get like that you check in with, but you're not really sitting in front of the terminal as much talking directly with the model. Like you're not like pair programming with the model these days, right? Ultra is like feels like a very interactive model where you can like kind of sit with it and do the work with the model. So yeah.
Awesome. Yeah, let's look at the output here.
There you
23
go.
seconds it cooked, and here we go.
It did the thing. I mean, this is what we want to see. Again, this is not a complex task. This is not like a PhD reasoning task or something like that. But the idea is that it extracted the relevant information from all of these papers, told us about the sizes of each of the models from each of the papers. We can see they're kind of small. That's the idea.
Yeah.
Good job, Ultra.
Well done. Well done. Cool.
And, okay, here's the thing. You can see the output format, very classic. We've got charts. We've got markdown. I will say, okay, so this is like not something that I think everyone's on board with yet, but I think a lot of our teams are. We're very happy to see Ultra do. Ultra's great at HTML, JSS. So if you are someone who is like, Markdown is dead, HTML is the future, Ultra's still a good model for you. It is good at producing like output artifacts that are more inherently visual. We had it make its own like launch video, so you might see that in some of the launch resources on Thursday. Yeah.
Great, man. That's very exciting.
Yes.
We should also say here that it's also pretty good at some coding tasks. I benched it and marked it on some internally as well. And I was quite impressed with out of the box. It would perform very close to the Frontier Lab models. Yeah.
It's neat because it's 550 billion parameters, right? Like, and we see labs releasing, trillion plus parameter models they're obviously like amazing, right? And then with whatever the size of the proprietary Frontier models are, but they're probably big, right? I just like seeing like a 550B model that's kind of punching in that same weight class. Super excited about what the team, and not just like the NVIDIA team, but like the Nemotron Coalition team is going to be able to bring with like Nemotron-4, right? And into the future. The idea that this is kind of, Nemotron-3 Ultra, amazing model, but we're already cooking on 4. and are really excited to see what the coalition brings.
Yeah, more to come, more to come.
Oh yeah.
Great. I think this is a good note to wrap it up. So, Chris, thank you so much for coming
course.
by. I appreciate you coming by every time. Hopefully, we'll get to do more of these in the future. And
Yes.
yeah,
We'll see you for 4.
yeah,
Okay.
sounds good. Awesome, dude.